Hello all. This video is about building a circuit in Miltisim. So before we build the circuit, I need to write down what it is I'm building. What is the logic expression that I'm trying to implement? So the logic expression that I'm going to have this time around is the logic expression for the original majority vote that some of you guys didn't turn in. So that one was F equals, that's final output, equals PT plus PV plus VT. So what it really says that any combination of president and treasurer, president and vice president and treasurer will actually get you a majority. All right, so let's go ahead and build the circuit. So let me actually highlight this and see if I can paste it into Miltisim. Nope. Okay. So what I'm going to do right now is I'm going to get myself a battery, because without battery nothing will work. So I'm going to go in power sources. This time I'm going to get a VCC. Why am I getting a VCC? Well, once you do the breadboarding, you understand, because I can have my positive end of my battery, my power, running through different parts of my breadboard. And it doesn't really make sense to build to grab a battery pack. So this is my VCC. And the second one is going to be my digital ground this time around, because I'm working with a digital circuit. Now, one thing I don't like about my screen right now, it's very white. It's very, it hurts my eyes after a while. So if that bothers you, right-click on the screen, go into Properties, and then go into Colors, and change your white background to black background. And you will see that, you know, the circuit elements that were black will automatically become yellow or white. So that doesn't really affect that. All right, so I've got my VCC, I've got my ground. What is the next thing? Well, if you think about our circuit and what it is we're building a table with voting switches, right? Switches are how we send our signals. So we need those switches. So I'm going to go into Place Basic this time. I'm going to go into Switch, and I will scroll all the way down to SPDT. So here's my lovely switch. Now here's the deal. This switch is backwards. So I'm going to go ahead and flip it horizontally. You can do that by right-clicking, and it says right here, flip horizontally. Or you can use Alt-X. So I'm going to use Alt-X. And now I'm going to go ahead and connect the switch. I'm going to connect one end into VCC and one end into ground. Now by default, my wire is always red. I don't like that because red is the reserved color for your power. So I'm going to go ahead and change the color of the wire that goes into the ground for white. And if you're one of those people who prefer to work on the white background, then your color is of course black. There we go. By the way, red and white and black, those are reserved colors. Anything else really? Not so much. So how many switches do I have? Well, let's take a look at our expression. I have exactly 3 people voting. That matters. Now, sure, we also have the poor secretary, you know, whose vote doesn't matter. But we can also always add an unconnected switch somewhere to our table later. This is just for the circuit. So I'm going to go ahead and grab the switch, and I'm going to copy it 2 times. And I'm going to go ahead and connect it, one end to the power and the other end to ground. I'm going to go ahead and grab my ground down a little bit so that it's... Now it seems to me like I'm running out of space a little bit. That's not a problem. I can always zoom out. So now you can see entire thing. All right. So notice that I have key equals space right here. So what does it do? Well, if I hit my space bar, you can see that it toggles my switch. Well, I don't want this all of the switches be toggled with the same key. So I'm going to go ahead and double click. I'm going to go into value. And this is my president, so I'm going to change the toggle key for P. And also when you guys are doing this, you will have a label over here. My labels are turned off by default, but yours are not. So I'm going to change my label from S1 to president. And you know, you can move around the legend a little bit so that it doesn't get in the way. I'm going to do exactly the same thing for this one. This is my vice president, so I'm going to use a V. And my label is going to be vice president. Yeah, it doesn't like spaces though. I have to say that. So don't use spaces. So once again, you can use your legend a little bit to make it a little more readable. And the last time is going to be my treasure. So I'm going to use T, and the label is going to be treasure. All right, so all of my switches are now done. Excellent. So let's take a look at my expression. So the next one should be logic gates. Now let's take a look at my logic gates. How many logic gates do I have? Guys, you have as many logic gates as you have multiplication or addition signs. Now, when you look at this expression, it's important to keep in mind that you don't have just 2 signs. You have 5. Remember, you can omit the multiplication sign. This expression is the same as this expression. So as you can see, when I rewrote it with explicitly written multiplication signs, I clearly have three multiplications and 2 additions. Well, multiplication is your AND gate. So I'm going to go ahead and select my AND gate. All right, so I have 2 types of AND gates that I could possibly use. Those are TTL and CMOS family. For this circuit, we're using TTLs because that's what I have in the classroom. Oddly enough, for our breadboarding simulation, we will use CMOSs because that's what they have. So we're going to go to TTL, and we're going to type in 74S08. And it gives you 3 options. I honestly don't care which one you pick. I'm going to take SO8N. And you will see that it's called quad 2 input AND. Now what does that mean? That means that this gate looks exactly like this. It has 4 AND gates. That's why it's a quad. And all of those AND gates have only 2 inputs. All right. So I'm going to go ahead and click OK. And immediately this menu pops up. A, B, C, D stands for those 4 AND gates that we have right here. Let's say this is A, B, C, D. Or maybe in another order. I don't know. It doesn't really matter because they're all the same. So I'm going to grab the gate A right here. And I'm going to put another couple of gates. Because remember, I had 3 multiplication signs. So I need 3 of them. And I will keep these out of the way for now. So let's connect my first expression. My first expression is P times T. All right. So here's my president. And once again, you can see the line is by default red. I'm going to change the color to orange. Well, that's not a very good orange. There we go. And the second line is my treasurer, so I'm going to go ahead down here and change it, and I'm going to color code it green. Now, does it have to be orange or green? No. You can use any other color except red, black, or white. So I don't really care which colors you color code them. So this is my first gate. Well, let's take a look at the second time. P times V. Okay. Let's grab a second one. So this time, it's a president again. So I can just connect it to the yellow wire. Times vice president. All right, I'm going to change my vice president to pink. All right. So that's my second gate. Very quick. And my third gate is V times T. So I'm going to grab my third gate. I'm going to connect this end into the treasurer and this end into a vice president. And all of my end gates are now connected. All right. So let's take a look at our expression. What do we have left? Well, we have these two OR gates. All right. So let's do it. So I'm going to go into TTL again. And my OR gate number is going to be 74S32. And once again, you have a choice, D or N. I'm going to choose N. It's a quad 2-input OR. So once again, it has 4 gates. And as you can see, I have chosen 2 OR gates because I need to. If you're curious, this is the pinout for the quad 2-input OR. We'll look at this a lot when we'll be doing breadboarding. But you can see it looks exactly like the pinout for the quad input and 2-input AND. You have 4 gates, each of them has 2 inputs, and they're all exactly the same. All right, so let's take a look at our expression. First, I have PT plus PV. All right, so this one gives me PT. I'm gonna make it brown. And this one gives me a PV. Make it blue. Now guys, you can absolutely label them. If you right click on the screen and you click on place graphic, you can place text. And I'm gonna place PT over here. And you can even choose the color your text will be. There we go. So now we have just one gate left. So let's take a look at our expression. So now I have to add PT plus PV plus VT. So if you like, I can rewrite this as PT plus PV, because we already connected those two, plus VT. All right, I can do that. So this one gives me PT plus PV. So let's connect them up. And I'm gonna go ahead and label that as well. And this one is VT. I'm going to go ahead and connect this as well. and go ahead and label this. Now guys, when you're building your circuit, you don't necessarily have to label it. I'm not gonna go crazy if you don't, but I do appreciate if you do color code it because it's much easier to read. Okay. All right. So I've got PT plus PV plus VT. So now in the output, I would have all three of them added together. So how can I test the circuit? Well, if I were to build an actual circuit, I would need to connect this all to a light bulb, probably through a relay or some kind of bridge to get one circuit to turn on in another, because I simply will not have enough power right now to actually get this thing working properly. But I don't want to do that right now. I just want to test this logic part of the circuit. So what I'm going to do is choose a probe. You can find probes over here where it says place indicator. It's this little rectangle with red dots. So I'm going to go ahead and click on it, click on the probe, and I will choose a red probe. Now a probe in real life is a stick that you can touch the wire with. It is technically speaking not a part of your circuit. So it is important to understand that the circuit you're looking at right now is incomplete, and that this probe is not in fact a part of the circuit. All it does is tells me, do I have a 1 or a 0 on the end? So now is the moment of truth. I need to figure out if my circuit is correct. So I'm going to go ahead and run my simulation. And you can see that my probe is dark right now. Now let's see if this is what is supposed to be happening. Well, my president's voting no. My treasurer is also voting no. Vice president is the only one voting yes, so of course he's outvoted. Okay, so what happens if the president votes yes? Oh, the probe comes on. What about if the president votes no and the treasurer votes yes? Yep. So what about if vice president votes no, treasurer votes yes, and president votes yes? Yep. So guys, you need to test for all the possibilities, and I strongly suggest actually comparing it to your truth table rather than your logic expression. And the reason for that is that you could have made an error while you were doing the simplification. So make sure you actually compare it to your actual logic expression. Okay, so after you do this, hopefully you are following along with me, you would need to show me the circuit, and you would also need to build a circuit for the revised majority vote circuit. So if you didn't have a good expression, simplified expression for the revised majority vote, I want you to build this circuit instead. And no, they will not have names other than A, B, C, or D. So if you did not arrive when you were working on your revised majority vote, the simplification just didn't work out really well, and you didn't get that circuit, you were not able to draw it out on paper, this is what you do. If you were able to draw your circuit out on paper, and you had some kind of logic expression, even if that logic expression was more complicated than this, then I want you to implement that one. And I hope that was helpful.